Today we're going to look at what makes all those names that we learned last week special. What is it about them that is true? We'll start with what's called the corresponding angles postulate. Now, you may be going, what the heck is a postulate? We talked a little bit about it at the beginning, but a postulate is a statement that is accepted true without proof. It's accepted as true without proof. For example, we've done some of those before, the angle addition postulate, the segment addition postulate. They just make sense. You look at it and you go, well, of course that's the way it works. And the same is true here for the corresponding angles postulate, which says that if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So if you've got parallel lines, like we do here, every pair of corresponding angles are congruent. So, for example, if we look here at angle 1 and angle 5, I want you to notice something. If I was to take angle 1 and just kind of slide it along the transversal, do you see how it would match up in exactly the same place and be exactly the same size as angle 5? So if I just took this angle that I outlined in blue, I don't know if I can move that or not. Hang on a second, let me see if I can. I don't think so, though. No, it won't let me do it. Let me try one other thing. Hang on just a second. Yeah. But if I just slide this angle over, it's going to fit on top of angle 5 exactly. Yes. No. Okay, guys, take care of your business during lunch. You just came from a half-hour lunch. You have plenty of time to take care of your needs. Okay? Let's get those taken care of before you get here. I want you to notice something. Well, we'll get to that in just a second. But all those pairs of corresponding angles are going to be exactly the same size. So angle 1 and angle 5 are going to be congruent. Angle 2 and 6 will be congruent. 3 and 8 will be congruent, and so will 4 and 7. How does that allow us to solve algebra problems? Well, if you look at this, these two angles are corresponding angles, and these two are marked parallel. Since these two are on the same transversal, those two will simply be congruent to each other. 2x minus 45 is equal to x plus 30. If I subtract x from both sides, and let's go ahead and add 45 to both sides at the same time, you get that x is 75. Any questions about that? So if you have corresponding angles and the lines are parallel, it has to be parallel lines. Let me show you why it has to be parallel lines. You don't need to draw this, but please just watch. So let's say I have an angle like this, or a line like that, and here's my transversal. Angle 1 and angle 2 are corresponding angles. Does angle 1 look like it's at all the same size as angle 2? Angle 1 is pretty clearly obtuse and angle 2 is pretty clearly acute, less than 90, more than 90. There's no way those two are going to be congruent to one another. So let's take a look at this diagram. And let's find them in the order that they asked us. If this angle is 110 degrees, and notice these two lines are parallel, so we're moving along the transversal from one side to the other. What kind of angles are the x and this 110 that I was given? What are they? That's how they're related. I was looking for what's the name given to angles that are in that position. What kind of angles are the 110 and the x? You did this a bazillion times on the homework. They're corresponding. These two angles are corresponding to one another. To be a linear pair, they have to be adjacent to each other. They have to be next to each other. So that means that x is 110. Then, what kind of angles are x and y? They're vertical angles. And what do we know about vertical angles all the time? They're congruent to each other. So that's 110. Then what kind of angles are x and z? Linear is a second word. Starts with a P. Yeah, they're a linear pair. What's true about a linear pair? Someone said it. They're supplementary. So if I take 180 minus 110, I get this angle is 70. And what's the measure of angle A? Well, what kind of angles are the 110 right here and A? Vertical, so they're the same. So here's what we should notice. What kind of angles are angle Y and the original 110? Yeah, they're alternate interior angles. When the lines are parallel, it turns out the alternate interior angles are congruent. What kind of angles are A and X? What kind? Very good. They're alternate exterior angles. When the lines are parallel, it turns out the alternate exterior angles are congruent. And then what kind of angles are the original 110 and Z? Same side interior. Very nice. Now, are those congruent? No. But what's 70 plus 110? 180. Okay? So they are supplementary. Guys, when you get a problem like this, it shouldn't take you any time at all to fill in all of these now that we have done this. Look, all of the big angles are 110. What do you think all the little angles are going to be? They're all going to be 70. If you know the measure of one of those angles, the other 7 should go really, really, really quickly. So, turn it over to the next page. Let's take a look. These are all theorems. A theorem is something we can prove is true based on previous knowledge. So a theorem can be proved true based on prior knowledge. So not only are the corresponding angles congruent when the lines are parallel, but if you have two parallel lines and a transversal, then the alternate interior angles are congruent. And so are the alternate exterior angles. The one that's different are the same side interior angles. If you've got two parallel lines that are cut by a transversal, then the same side interior angles are supplementary. And I think it's easy to remember that because what does same and side, what letters does that start with? This isn't a trick question. Let's see if you're awake. What letter does same and side start with? S. What does supplementary start with? S. Okay? It's really simple to keep track of which one is different. So in this diagram, we know that angle 2 will be congruent to angle 6, and that angle 7 will be congruent to angle 3 because of the alternate interior angles theorem. This, by the way, is the way I abbreviate theorem. I don't remember where I picked that up. Somewhere in college, one of my professors did that. Likewise, alternate exterior angles are congruent. 1 and 5, 8 and 4. And then the same side interior angles like 2 and 3 and 6 and 7 are supplementary. So let's take a look at some example problems. So on this angle, it asks you to find the measure of angle TUS. When you look at these two, the first thing I need to do is go, okay, what type of angle, if any, are these two angles? Someone started to say, I didn't hear it. Same side interior angles. Remember, the one that starts with S is the one that's supplementary. So these two angles need to add together to be 180. 13x plus 23x is 180. Group the like terms. That's 36x is 180. Divide both sides by 36, and I get that x is equal to 5. Notice they didn't ask me for x, though. They asked me for the measure of angle TUS. So the measure of angle TUS, that's this angle right here, is 23 times x, so that's 23 times 5 is 115 degrees. And honestly, on these problems, if you look at these, this angle is acute. This angle is obtuse. There's no way they can be equal to one another. The only other relationship we have in this unit is that they're supplementary. They're either going to be equal to each other or they're going to add up to 180, one or the other. And honestly, it's really hard to hide. It's really hard to make a trick question about these because the diagrams look like what they are. If they're both acute, well, they're congruent to each other. If they're both obtuse, they're going to be congruent to each other. If one is acute and one is obtuse, well, they're going to add up to 180. So let's take a look at this one. So, in this diagram, is this angle acute or obtuse? It's acute. How about this angle? Is that more or less than 90? It's less. So is this one. These are going to have to be congruent to each other. Now, you are going to be asked why at some point, but for right now, just look at them. They're both acute. What type of angles are these? Alternate interior. So when lines are parallel, alternate interiors have the same measure. 2x plus 10 is equal to 3x minus 15. I'm going to subtract 2x from both sides and add 15 to both sides. And I get that x is 25. I want the measure of angle ABD, that's this angle up here. So the measure of angle ABD is 2 times 25 plus 10. It's 50 plus 10 is 60 degrees. You should, yes, because these were congruent. 3 times 25 is 75, minus 15 is 60. All right, one more, and this one's a little bit more difficult. Because there are two different variables here. We always want to be moving across along the transversal, across the parallel lines. So like on this one, there's no relationship, don't underline these, between these two angles. Because if we're going this direction, we're crossing two lines that I don't know are parallel. There's no mark there to show that they're parallel. I want to be going this direction across the two parallel lines. So again, the first thing I do is just look at it. Is this an acute angle or an obtuse angle? Do you think this is less than 90? It's pretty clearly obtuse. And this one? It's also obtuse. What type of angles are those two? They're not corresponding. Yeah, they are alternate exterior angles. So we have a theorem that says those are going to be congruent. So one of my equations is going to be 25x plus 5y is equal to 125. Now, unfortunately, I can't solve that because it's got two different variables in it, both an x and a y. I'm going to need another equation. Well, let's look down here. What type of angle is this? Is it acute or obtuse? Obtuse. This one? Acute. They're not the same. They're going to add up to 180. What name is given to these two angles? Same side interior, exactly right. So these two are going to add up to 180. So I'm going to go 25x. Oops, accidentally wrote x twice. If this one's obtuse, it's bigger than 90. If I look at this angle, is that angle bigger than a right angle or smaller than a right angle? It's bigger, so that's obtuse. Whereas this one, see how the sides, see how it's narrower? That's an acute angle. So this is going to be 25x plus 4y plus 60 is equal to 180. All the problems you're going to have right now that are like this, we can solve in the same way. I'm going to subtract 60 from both sides just to get all the numbers on one side. So this would be 25x plus 4y is equal to 120. I'm going to write that equation right underneath this one. 25x plus 4y is equal to 120. One of the things you did in algebra would be to combine two equations. And I'm going to combine these by subtracting, because that makes the x's drop out. 25x minus 25x, there's no x's left. 5y minus 4y leaves me with just y, or 1y. And 125 minus 120 leaves me with 5. I'm sorry?
So why couldn't we do like 25x plus 5y equals 125?
Do what with it?
Just solve it, you know?
Because it's got two different variables. If you have two variables, you can't solve the equation. The number of variables has to be equal to the number of equations that you have. So now that I know what y is, I can substitute back into either one of these. It doesn't matter which. I'm going to substitute back into the second one. I'll have 25x plus 4 times 5 is equal to 120. 4 times 5 is 20, so I'm going to subtract 20 from both sides. So I get 25x is 100. And then dividing, I get x is equal to 4. So x equals 4 and y equals 5. All right, you do have some time, so please go ahead and get started on your assignment, which is in the book.